Hi, this is Parameswarappa Samani. The today's presentation topic is the Bimotor System Prototype Presentation. The introduction: the Bimotor System is a software prototype designed to modernize and automate the operations of garage. It is tailored to meet the needs of two primary user roles, that is, manager and mechanics, offering a streamlined way to manage tasks, customers, and vehicles. The system leverages advanced object oriented principles and design patterns to deliver a user friendly and robust solution. And the purpose of the system is to enhance the efficiency and user experience of garage operations by automating key processes such as customer registration, task assignment, and notification handling. The Bay Motor system is reduces manual errors, improve service speed. Managers and mechanics provide relevant features, reducing complexity by making it more usable. Customer and vehicle management: the manager can register customers, log vehicles details, and manage customer upgrades. Task assignment and tracking. I mean, in the above use case diagram, uh, the use case diagram explains about the task assignment and the tracking manager. Responsibilities and roles about the manager and mechanic, and responsibility about the customer also. The task assignment and tracking: managers can assign tasks to mechanics based on priority, while mechanics can view and complete tasks systematically. And the notification system: it automatically sends notification about the status regarding their vehicle or any promotional offers to customers. And the and this matter is, about the use case diagram. The use case diagram shows the interactions between the bay motor system and actors. Customer registration: the manager or mechanic creates a record of the customer and car, and also the task assignment and upgrade customers also. And the class diagram figure: the overview of the class diagram slides provides a detailed explanation of the system's structural design, focusing on the key classes and their relationships. This slide illustrates how object oriented principles like inheritance, association, and encapsulations are applied to create a modular and maintainable system. The key classes in the system are user. The base class for all users is the base class for all users of the system, and the manager is a subclass for the user. The manager responsible for administrative tasks like customer registration, task assignment, and supplier management. And also the another subclass for the user is mechanic, and and these mechanic responsibilities are focused on task completion and viewing assigned tasks. And another subclass of the user is a customer. The customer represents the customer interacting with the garage with attributes like name, contact details, and email, and the registration number. And the next one is state vehicle. The This vehicle stores a vehicle specific data and links to this owner. And also task represents tasks assigned to mechanics with the details like task description, status, and associated and vehicle mechanic. And manufacturer, I mean maintains these manufacturers maintains details about the vehicle manufacturers and part suppliers, and these part suppliers tracks information about the suppliers associated with the manufacturers. And also the class diagram: all system users belong to the basic class, and the manager and mechanic and the customer and the vehicle, all the explain about the all the class diagram. Another category of users, mechanics, are responsible for, which I would explain about the class diagram, all the matter in this class diagram. customers. This represents the consumers coming to the garage for service, such as providing their name, contact information, and registration status. And the polymorphism, on the definition of polymorphism is the ability of the objects to be used interchangeably through a shared interface or a parent class. And the implementation in the Bay Motor system, polymorphism is implemented through the user class, which is parent of the classes manager and mechanic. In the Bay Motor system, polymorphism is implemented through the user class, which serves as the parent class for mechanic and manager. The user class defines common attributes like ID and name and an abstract method display menu. Subclasses manager and mechanic override the display menu and method to provide role specific functions for instances. Managers access point options for customers registration, task assignments, and supplier management. Mechanics access options for viewing and completing assigned tasks. When a user as a login, the system dynamically determines their roles and responsibilities and displays a menu tailored to the role using polymorphism. This approach minimizes redundancy and centralizes shared functionally in the user class. And the next one, design patterns. And factory design pattern, composite pattern, observation pattern. The factory pattern, the purpose of the factory pattern simplifies object creation by encapsulating the installation logic. It allows dynamically creation by the user. And composite pattern, this uh, purpose, this manages the grouping of tasks, enabling individual tasks and groups of the task to be treated uniformly. And the user observe pattern, the aim of the observe pattern to be able to communicate with the customers from the system by providing notifications in case of an event on point, such as task completion or promotional offer. And the exception handling, example example of implemented exception handling: customer registration or validation. Checks for duplicate customer ID during registration. If a duplicate ID is detected, the system throws an exception and prompts the user to correct their input and prevent data inconsistency and ensures the uniqueness of customer records. Task assessment and completion validates task IDs during assessment or completion. If an invalid task is entered, the system catches the error and notifies the user. Avoids assigning tasks to non-existent vehicles or mechanics. And this is the input for the code and test results. Customer management success and the problem example in this test results. I will explain about the customer manager problem example test case. And the customer manager is also success. New customer successful registration was verified. If in case the system detects the duplicate ID handling was tested and responded as expected. Problem: delay in performances when it deals with a huge data while bulk import of customers. This will be optimized on future iterations. Example test case: input register as a new customer whose ID is C123. Expected output as a customer is added to the system. Actual output is success. And the reflection: objected orient the challenges and faced debugging task related bugs in the composite pattern. While grouping tasks using the composite pattern, some some edge cases involving nested tasks groups caused expected behaviors. These bugs required extensive debugging and restricting of the task hierarchy, testing edges cases for large scale data handling, and managing the large data sets during the customer registration and task assignment introduce performance challenges. And the edge cases such as handling empty tasks And the customer task ID validation and performance issues with large data sets remain unsolved. These are the documented and provided a basis for further iterations. And the summary of achievement: successfully implementation of a scalable prototype. The Bay Motor system is a robust prototype designed to ease many operations in the garage. It effectively supports role-based functions for managers and mechanics, and it modular and scalable also. And the application of object-oriented principles. The project shows deep understanding in object-oriented concepts of inheritance, polymorphism, and encapsulation. These principles, combined with the design patterns like factory, composite, and observe, enhance the maintainability of the system. And the closing, a heartfelt thank you to the tutor and the PETS instructors and collaborators. Thank you so much.